Welcome to Astronomy Daily, your exciting look at the very latest in space news. I'm Anna, and today we're diving into a cosmic journey that spans from groundbreaking new telescopes revealing deep space mysteries to critical Earth observations and the latest in human spaceflight. We've got an incredible lineup for you. We'll explore the first breathtaking images released by the new Vera Rubin Observatory, discuss a potentially dramatic close call with an asteroid that could impact the moon, and update you on a private astronaut mission heading to the International Space Station. Plus, we'll delve into the decoding of an ancient radio signal that the universe tried to keep secret for billions of years, and marvel at spectacular new views of Earth from orbit, thanks to ESA's biomass satellite. Get ready for an action-packed episode. The astronomical community is buzzing with excitement as the Vera Rubin Observatory has officially released its very first images of space. This momentous occasion heralds a new era of discoveries about our universe. Perched atop the Cerro Pachon Peak in the Chilean Andes, this giant telescope is designed for an ambitious 10-year mission to create an unprecedented time-lapse video of deep space, providing a comprehensive view of the entire southern hemisphere's sky every 3 days. Rubin's true claim to fame lies in its imaging powerhouse, the world's most powerful digital camera. It's a 3.2 billion pixel behemoth known as the Legacy Survey of Space and Time, or LSST. For perspective, the latest iPhone has a 48 million pixel camera. The LSST alone weighs 3 tons and features an 8-meter wide mirror. This incredible instrument will allow astronomers to capture details far beyond what was previously possible. Named in honor of pioneering American astronomer Vera Florence Cooper Rubin, whose groundbreaking work provided the first direct evidence for dark matter. The observatory is poised to help answer some of the cosmos's deepest questions. These include the nature of dark matter and dark energy, and how galaxies have evolved. Thousands of astronomers globally will rely on the vast amounts of data Rubin will generate. It's expected to deliver an astounding 10 million alerts every single day, flagging objects that have either changed position or brightness. Some alerts could reveal entirely new cosmic phenomena. As Professor Rachel Webster from the University of Melbourne, who leads Australia's collaboration, puts it, in reality, there is so much we still don't know about the universe, so the scope of what may be discovered is what's really exciting. Professor Webster explains Rubin will survey the entire southern sky with an agnostic approach, expecting unexpected new things. This includes very faint, diffuse objects and sudden, transient events, things that go bang in the night or explode and change brightness rapidly. The success of Rubin also relies on advanced technology and international collaboration, leveraging cutting-edge tools like artificial intelligence. Its data will complement the Square Kilometer Array telescope, currently under construction, promising to significantly advance our understanding of dark matter, dark energy, and even how supermassive black holes interact with their environments. And a sample of what can be achieved. In just 10 hours of observing the night sky, the powerful new telescope detected more than 2,000 new asteroids, including a few that will pass near Earth. Incredible! This truly represents a thrilling leap forward in astrophysics. From the awe-inspiring depths of the universe, we now turn our attention a little closer to home, to a celestial body that might just have a very eventful year in 2032, our moon. While initial worries about a direct impact on Earth have thankfully been ruled out, a new study suggests that a city-killer asteroid named 2024 YR4 might still be headed for a dramatic encounter, not with us, but with our lunar companion. This asteroid, approximately 60 meters wide, was briefly the subject of concern earlier this year, with a 3.1% chance of hitting Earth in December 2032, a significant probability for a space rock of this size. Subsequent observations from telescopes put those fears to rest for our planet. However, new data from the James Webb Space Telescope in May has nudged the odds of it crashing into the moon up to 4.3%. If this happens, it would be quite an event. Lead study author Paul Wiegert from Canada's University of Western Ontario estimates it would be the largest asteroid to strike the moon in around 5,000 years, releasing energy comparable to a large nuclear explosion. Simulations indicate that up to 100 million kilograms of material could be shot out from the moon's surface. Now here's where it gets interesting for us down on Earth. If the asteroid were to hit the side of the moon facing our planet, which is roughly a 50% chance, Up to 10% of that ejected debris could be pulled into Earth's gravity over the following days. While our atmosphere would protect the surface from these millimeter to centimeter-sized lunar rocks, these fast-moving particles, described as being a lot like a bullet, could pose a serious threat to our orbiting satellites. By 2032, we expect a much larger number of satellites orbiting Earth, and an impact could lead to more than 1,000 times the normal number of meteors threatening them. For those of us on the ground, however, this cosmic bullet train could mean a truly spectacular meteor shower lighting up the night sky. It's important to remember that the current odds of a direct hit on the near side of the moon remain at just 2%. We won't get another clear look at Asteroid 2024 YR4 until 2028. So for now, it's a waiting game. But if a direct lunar hit does become likely, scientists believe humanity would have enough time to plan a mission to potentially deflect it, much like NASA's DART mission successfully altered the trajectory of Dimorphos in 2022. Though, Wiegert cautions that deflecting something zooming so close to Earth could be a little dangerous. This fascinating research is currently a preprint study, awaiting peer review and submission to the Astrophysical Journal letters. Shifting our focus from potential lunar impacts, let's turn to the exciting world of private spaceflight, where humanity continues its push into low Earth orbit. SpaceX and Axiom Space have just announced a new launch date for the AX-4 mission to the International Space Station, bringing us another step closer to a more accessible space for astronauts from around the globe. The four-person crew is now slated to lift off aboard a SpaceX Crew Dragon spacecraft atop a Falcon 9 rocket no earlier than June 25th at 2:31 a.m. Eastern Daylight Time from Launch Complex 39A at NASA's Kennedy Space Center in Florida. You might recall this launch was previously delayed last week due to a leak detected aboard the ISS's Zvezda module. While the leak itself isn't new, a change in its pressure data prompted NASA and Axiom to postpone the mission to ensure safety. No update on the leak's current status was provided with the new launch announcement, but the green light suggests confidence in the station's integrity. This mission is set to be a landmark one for several reasons. The AX-4 crew will be led by former NASA astronaut and Axiom's Director of Human Spaceflight, Peggy Whitson, who will serve as mission commander. Joining her are Shubhanshu Shukla from India, Sławomir Uznański-Wisniewski from Poland, and Tibor Kapu from Hungary. What's particularly exciting about this crew is that for Shubhanshu, Sławomir, and Tibor, this will mark their nation's first ever astronauts to launch on a mission to the ISS. It's a fantastic testament to the expanding international participation in space exploration. The mission is expected to last 2 weeks, and during their time aboard the orbiting lab, the AX-4 crew plans to conduct an impressive number of activities. They're scheduled to undertake more than 60 science experiments and STEM, that's science, technology, engineering, and math outreach events, surpassing any previous Axiom mission. If all goes according to this new schedule, the crew's Dragon spacecraft is slated to dock with the ISS at approximately 7 a.m. Eastern Daylight Time on Thursday, June 26th. It's an exciting time for private spaceflight, showcasing the growing capabilities and collaborations that are shaping the future of human presence in space. From the immediate future of human spaceflight, let's now journey back in time, billions of years, to unravel one of the universe's most ancient and secretive messages. Scientists are beginning to decode a mysterious radio signal from deep space that has been hiding secrets about the universe's earliest stars, offering a rare glimpse into moments the cosmos tried to keep from us for eons. In the vast, dark expanse of the universe, there's a profound mystery surrounding the first stars, those massive, luminous celestial bodies known as Population 3 stars that illuminated the cosmos in its earliest stages. These stars are so incredibly distant in time that their properties have remained largely unknown, despite decades of scientific inquiry. But now, a new method is bringing them into focus, using faint signals emitted billions of years ago. The breakthrough lies in a subtle, almost undetectable radio signal that has persisted through time, the 21-centimeter signal. This cosmic whisper, emitted by hydrogen atoms shortly after the Big Bang, serves as a crucial marker from a period known as the Cosmic Dawn. This was the pivotal moment when the very first stars began to form and light up the universe. What makes the 21 centimeter signal so incredibly valuable is that, unlike visible light or X-rays, it can offer direct insights into the masses, behaviors, and distribution of these elusive first stars. Until recently, however, astronomers hadn't fully grasped how this delicate signal could truly unlock the secrets of the early cosmos. An international team of astronomers, led by Professor Anastasia Fialkov at the University of Cambridge's Institute of Astronomy, has cracked a crucial aspect of this signal. Their groundbreaking work, published in Nature Astronomy, reveals that this ancient radio signal is remarkably sensitive to the properties of these initial stars. Specifically, their research suggests that the signal could be used to estimate the masses of population 3 stars, whose light we can never directly observe. This insight is truly significant, opening a new door to understanding the early universe, which was primarily composed of hydrogen and helium. By studying how the 21 centimeter signal has been altered by these stars, astronomers can begin to map the transformation from a dark, uniform mass to the complex and diverse cosmos we see today. This monumental effort is being supported by 2 ambitious projects: REACH, or the Radio Experiment for the Analysis of Cosmic Hydrogen, and the Square Kilometer Array, known as SKA. REACH is currently in its early calibration phase, using radio antennas to capture the faint 21 centimeter signal. The SKA, on the other hand, is an even larger array of antennas under construction, poised to map vast regions of space and study fluctuations in cosmic radiation, providing an invaluable resource for understanding the earliest epochs of the universe. These projects are absolutely essential to the future of radio astronomy, focusing on statistical patterns of faint signals to study the early universe in unprecedented detail. Professor Fialkov's team predicts that both REACH and SKA will allow astronomers to study the distribution, luminosity, and masses of population 3 stars, deepening our understanding of the forces that shape the cosmos in its infancy. One of the most fascinating aspects of this research is its exploration of how X-ray binaries, pairs of stars where one is a collapsed object like a black hole, impact the 21 centimeter signal. These binaries are thought to have played a significant role in the early universe by emitting high-energy radiation that affected the surrounding gas and, consequently, altered the 21 centimeter signal. Professor Fialkov's team developed a model incorporating the effects of X-ray binaries, suggesting that previous studies might have underestimated their influence. This discovery adds another layer of complexity to our understanding of how the first stars shaped the universe, making the 21 centimeter signal an even more powerful tool for mapping the earliest moments in cosmic history. The potential of the 21 centimeter signal is further amplified by the increasing power of radio telescopes. Unlike optical telescopes that capture detailed images of distant stars and galaxies, radio telescopes like REACH and SKA rely on detecting these faint signals to infer the properties of cosmic phenomena. While they won't provide direct images of individual stars, they offer an extraordinary opportunity to study large-scale patterns in the universe's earliest phases. As Dr. Eloy de Lara Acedo, principal investigator of the REACH project, notes, these radio observations are essential for understanding the mass and properties of the first stars, laying crucial groundwork for future discoveries. Now let's shift our gaze from the incredibly distant past to the immediate present, and a new eye watching our own planet. Cheers and excitement erupted at ESA's Living Planet Symposium in Vienna with the release of the first images from ESA's biomass satellite. These striking views offer a spectacular new window into Earth's forests, deserts, and glaciers, marking a major milestone in our understanding of how our planet stores carbon and how vital ecosystems are being transformed. Just 2 months after its launch, the biomass mission is already delivering on its promise, providing a glimpse into the incredible potential of its novel radar system. While still in its commissioning phase, fine-tuning to ensure the highest quality data, the early images are clearly showcasing the satellite's capabilities. Michael Feringer, ESA's biomass project manager, described these first images as nothing short of spectacular, emphasizing that they are only a mere glimpse of what's still to come. Simonetta Celli, ESA's Director of Earth Observation Programs, shared the emotional impact of seeing the results, calling it very symbolic of the effort behind the scenes and the potential that this mission has. What makes biomass so revolutionary is its unique P-band radar. Unlike other satellites, this penetrating radar system captures the full vertical structure of forests beneath the canopy. For instance, in images from Bolivia, where rainforest meets riverine floodplains, biomass highlights distinct ecosystems like green rainforests, red forested wetlands, and blue-purple grasslands, all while the dark, snaking Beni River cuts through the landscape. When compared side by side with images from Copernicus Sentinel-2, it's clear that while Sentinel-2 is limited to surface features, biomass unlocks a crucial 3D view of forests, vital for accurate carbon accounting. The satellite has also provided striking views over the northern Amazon rainforest in Brazil and the mountainous Halmahera rainforest in Indonesia, revealing subtle terrain and vegetation differences even in dense, ecologically critical areas. But its capabilities extend far beyond forests. Biomass has shown its incredible power in other extreme environments, like the Sahara Desert in northern Chad. Its P-band radar can penetrate up to 5 meters below the desert surface, exposing hidden structures like ancient riverbeds and geological formations long buried beneath the arid terrain. This capability opens new frontiers in paleoclimate research and groundwater mapping, offering insights into Earth's past. Furthermore, in the frozen expanse of Antarctica, biomass has peered into the Nimrod Glacier and the Trans-Antarctic Mountains, demonstrating its ability to track internal ice structures and flow velocities. This is crucial for understanding ice sheet dynamics and stability, which are critical factors in predicting future sea level changes. While these initial results are still raw and not yet fully calibrated for scientific analysis, they unequivocally confirm that biomass is well on track to meet and potentially exceed its ambitious goals. Designed to span 5 years, this mission will provide consistent global coverage of Earth's forested regions. The data it collects will be vital for improving climate models, supporting global conservation efforts, and refining carbon accounting. As the biomass satellite transitions into full operational mode, scientists around the world are eagerly anticipating the comprehensive datasets that could truly transform how we monitor and protect the living lungs of our planet. We've journeyed through a wide range of cosmic updates today, exploring everything from the profound mysteries of the universe's distant past, thanks to signals hidden for billions of years, to the immediate future of human spaceflight as private astronauts prepare for the ISS. We also looked at potential close calls with asteroids and how new satellite technology is revolutionizing our view of Earth's precious ecosystems. Thank you for joining us on this episode of Astronomy Daily. I'm your host, Anna. Before we sign off, remember you can always catch up on all the latest space and astronomy news with our constantly updating newsfeed on our website, astronomydaily.io. While you're there, you can also listen to all our back episodes. Don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts, so you never miss an episode. Until tomorrow, keep looking up.